This is the solution to written homework 31. What's being requested here, each one of these is an example of a difference quotient. These particular difference quotients, of course by now you know, are used in computing the partial derivatives of f, but there's no limit here, so these are not partial derivatives. Okay, so then part A, let's evaluate this. So this would be f of x plus h comma y. So I'm going to evaluate just that part first. So that would be 5 and then x plus h cubed plus y squared. So I'll evaluate that. So this would be 5 and then x cubed plus 3 x squared h plus 3x h squared plus h cubed plus y squared. Oh no, I was leaving off the 3. So this 3 was left off for some reason, and this 3 from this 3. Okay, then plugging or distributing this. This is then 5x cubed plus 15x squared h plus 15x h squared plus 5h cubed plus 3y squared. Okay, then now that we have this, computing the difference quotient is easier. So then 5x plus h y minus, f of x plus h y minus f of x y over h is this expression minus this expression. So it will be 5x cubed plus 15x squared h plus 15xh squared plus 5h cubed plus 3y minus 5x cubed plus 3y squared divided by h. There's lots of cancellation that occurs. So this 5x cubed cancels with that one, and this 3y squared cancels with that one. So then this would be, what remains is 15x squared h plus 15x h squared plus 5h cubed over h. And then in lecture I pointed out that you cannot cancel the h's generally, but on this specific exercise I specified that h was non-zero, so that means that you can cancel an h, and when you do that you get 15x squared plus 15xh plus 5h squared. And notice now, we said h is non-zero, but if suddenly for some reason h became equal to 0, then this would be 15x squared, which is of course the partial derivative of this expression with respect to x. So that's the answer to part A. Part B, I'll take a similar strategy. F of x y plus h is 5x cubed plus 3y plus h squared. So this would be 5x cubed plus 3 y squared plus 2yh plus h squared. So this is 5x cubed plus 3y squared plus 6yh plus 3h squared. So now we can compute the difference quotient, f of x comma y plus h minus f of xy over h is this expression, 5x cubed plus 3y squared plus 6yh plus 3h squared minus 5x cubed plus 3y squared over h. Again, many terms cancel. The terms that cancel are these two. So then what remains when you do that is 6yh and 3h squared over h. And then we can cancel an h, and you get 6y plus 3h. And of course, the reason why we can cancel is because h is non-zero, as specified at the beginning of the exercise. But if for some reason, if we could now insist that h is 0, then the result would be 6y, which of course is the partial derivative of this expression with respect to y. So for those of you that are wondering, maybe wondering, how did I do this so quickly? How did I cube this expression, and how did I square this expression so quickly? The reason is that most mathematicians and many math students memorize the first few rows of Pascal's triangle. So Pascal's triangle is this. So 1, and then 1, 2, 1, and then 1, 3, 3, 1, and then 1, 4, 6, 4, 1. So the reason why I knew this is because those are the coefficients, 1, 3, 3, 1, 1, 3, 3, 1, and 1, 2, 1, 1, 2, 1.